Hi, and welcome to our first video lesson for AP Statistics this year. Today's topic is data exploration, as you can see from the title of the notes. And really today and tomorrow we'll be doing a real quick overview of what statistics is all about. And basically there are two parts to it. The first is just what it says, data exploration. That includes things like collecting data, analyzing data, displaying data. And then tomorrow our focus will be on making sense of the data that you've collected, that is inference. Or you might think of it as, okay, I've collected all this data. What does that mean about real life? And is my data acting the way that things do in the real world? Those kinds of questions. Inference is the title of that lesson, but we'll get there tomorrow. Today we're going to start talking a little bit about statistics, where you can see that we're going to open with some vocabulary. And what I'd like to do is have you take a look at your textbook. I'm going to bring this data table out where you can see it, or try. And this table is found in your textbook on page 6, I believe. This is part of a listing of folks who had jobs at a company called Westvaco. It's an envelope manufacturing business. And as many businesses did, this one had trouble in the 90s. They decided that they needed to downsize. They were not being productive enough, apparently. And so in the engineering department, they had some hourly employees, which we're looking at a listing of those hourly employees' job titles and the month that they and year that they were born, their hiring date, their age at their birthday in 1991, which is when this scenario took place. And it says round here. That round means the round of layoffs. Yeah, folks, this is not good. Westvaco decided that they needed to cut out everything that they could, downsize a lot, and so their managers were told in each department to look at their employees and eliminate as many as they feasibly could. In round one, you can see that 4 hourly employees were going to be let go. Well, the bosses go back to the big bosses and they showed them their list, and the big bosses said that's not enough. They went back a second, a third, a fourth, and even a fifth time, cutting people out of their department. In engineering, no hourly employees got laid off in the fifth round. However, they did lay people off all the way through. Those with zeros here, those are the only engineering employees who did not get laid off. We're going to refer to this data set quite a lot. In fact, this company, Westvaco, and the people who work for them are going to be part of our discussion for quite a while to come. I'm going to slide that off to the side. And I want you to think about this. We said we're going to look at this table and make some sense of vocabulary. Ladies and gentlemen, the cases in a statistical study are the objects or subjects that are being studied. That is, the objects or subjects that are being studied. And for us today, we're going to focus on those employees in the engineering department. Specifically, we're going to look at the hourly workers, although there were salary workers as well, which you will see when you look at your the table in your textbook. Cases are the objects that are being studied. In this case, they are the employees. And you can see that each line in this table represents one case then. It represents one employee. So if I put out here on the side that the rows in this table are the cases, I think that you'll remember what we mean. It's the people. The variables, well, those are the characteristics that are in question. And if you think about that, the characteristics being studied or in question, if you think about that in terms of this table, you can see that one characteristic for each person that's listed is the name of their job title, their pay situation, whether they were hourly or salary, the year and month in which they were born, the year and month in which they were hired, the round that they were laid off in, or if they weren't laid off, and finally their age in 1991 when this layoff situation happened. So the deal is, folks, this company decided to downsize like many companies did, and one of their employees thought that their layoffs were not fair. He thought that they were discriminating against older workers and brought a legal suit against them. So this is real life, folks. This has really happened in this company, and the employee, whose name was Martin, I believe, he sued the company for age discrimination. All right, if variables are the characteristics being studied, then variability means the differences in the variable. And if you think about that, differences in the variables, the difference that we're going to be interested in is in their ages on the layoff year. How old were they? The variability is the differences in the variables. A distribution, folks, is just a listing of all the variables and the values that they take on. A listing of the values of the variables. And how often those things occur. So you might think about a distribution in age being all the various ages that are covered here and how often each of those ages occurred. So it's a listing of the values of the variable and how often they occur. All right. A dot plot, folks, is a graphical display of a distribution. A dot plot uses the x-axis as a number line, so it uses a number line for the x-axis. And it's a real good display for us to just get a preliminary look at data to see if we can see any trends. It uses a number line for the x-axis and places a dot then for each case. So it's a way of looking at a distribution. There are many different ways to display data. The dot plot is one. In this course, we'll talk about the histogram, which is a close relative of this, the stem and leaf plot, the box and whisker plot, plus those graphs for showing categorical or not numeric data, things that we're used to like pie charts and bar graphs. All those things are ways to investigate what a data set looks like. All right, what we want to do here, it says, is construct a dot plot similar to display 1.3 on page 6, comparing the ages of hourly workers who lost their jobs during rounds 1, 2, and 3 to the ages of hourly workers who still had their jobs after round 3. Folks, we're going to create ourselves a little dot plot based on this data set, and so I want to drag that data over here where I can see it. All right, as you look at the hourly workers here, folks, their ages range from, well, there's a 25, there's a 56, 59, 64, wow. So basically from the 20s to the 60s. What I'm going to use as the number line here is going from 20 by 5s. And what we're going to do is place a dot for each of the hourly workers who lost their jobs during rounds 1 and 3, or 1 through 3. So that would be this set of employees right here, 65 and 70. Good. And now let's go ahead and put a dot up there for each of these workers. Our first worker, our first hourly worker laid off in round 1 was 53 years old, and that might be right about there. Obviously, we're guesstimating a little bit. Our second worker was 55, so there's his dot. 59, so almost up to the 60. A 22, oh, there's a young one. A 55. A 64, that's the most elderly of those that were laid off. A 55, that seems pretty common right there, and another 55. A variety of ages, folks, from 22 all the way to 64, but it's easy to see in the first 3 rounds that many of the employees laid off in those rounds were older. So maybe Martin does have a case here against the company Westvaco. Let's take a look at the ages of those who were retained, and that would be in this data set anyone who has a 0 or these 4s, because we're only doing 1 through 3. So I'm going to go ahead and number this again and ask you to do the same. And it's kind of important that we look at these number lines on the same scale with the same spacing so that we get a fair and accurate picture of our data set. The first retained employee, 25. The next one, 38. Then 56. 48 again. Let's see, right about in there. Those are our, we never got laid off at all. And then we also have to pick up these two employees, 33 and 35, who were good after the third round of layoffs, but not after the last round. I'm going to move the data set aside so that we can answer the question here. This is asking for our opinion. How do the ages differ? So I'd love to have you take a moment, look at your data set, and answer this question, please. We want to use complete sentences in our answers. In statistics, very often they ask for our opinions, but our opinions should be stated in a professional manner, if you will. So you pause the video perhaps and write your sentence, and then let's turn it back on and see if we agree. All right, this is what I would say. How do the ages differ? The laid off employees, for the most part, appear to be older. Whoops, that should be an E. Appear to be older. And I'm referencing a clump of data up here at the high end, whereas this data is all spread out. The retained employees are scattered along the age line. All right, that's my answer for this. Again, that's my opinion. Yours doesn't have to be like mine. We both get to have a say, which is a nice thing in statistics. Let's go on and see what else. We've looked at a dot plot. We've looked at a table of data. Another way that's frequently used to analyze data is a table that groups variables in certain ways. This is called a two-way table. Some places they call it a contingency table. But you can see that the variables that they grouped were whether an employee was laid off or retained, and by age, whether they were under or over 50. Okay? As you look at that, we're talking about a total of those 14 hourly workers. Okay? So the total is here. 6 of them were under age 50, 8 of them were over. 10 of them were laid off, 4 were retained. All right, and the question here that we're going to answer, what proportion of hourly workers under age 50 were laid off? Ladies and gentlemen, what we're choosing for our answer is going to be a fraction. And what we're choosing from are hourly workers under age 50. So we are looking at these 6 employees right here. What proportion of those were laid off? Well, it was 3 of 6, or 1/2. Half of them were laid off. By the same token, half of them weren't laid off. So that looks like it might have been pretty fair if you think about that. Of the employees under 50, they were 3 and 3, 50-50 chance that you got laid off or not. The next series of questions ask us for the proportion of laid off hourly workers. So now we're in this column where there were 10 employees. So the bottom of our fraction is going to be 10. We're selecting from these 10. The proportion who were laid off but under age 50, only 3 of them. So 3/10 is that fraction. The proportion of laid off hourly workers then who were older, 50 or older, would be the remaining 7/10. And I'd love to have you think about this. Of what we've shown on top, which 2 proportions should you use and compare if you want to decide whether older hourly workers were laid off in a disproportionate way? I know what I'm thinking. Decide whether older hourly workers were disproportionately laid off. Laid off is the key to me in that. And so I'm thinking that the proportions, the 2 ratios we should look at, are these 2 that we just computed. Okay? These will tell us whether folks who were older were laid off. So it's the final 2 proportions I'm going to put here, the last 2. over ratios or proportions. What's my conclusion? Well, you can tell I'm giving you kind of my opinion through here. Your opinion may not agree with mine, but it looks to me like there might have been some age discrimination going on. So I'm going to write that here. There may have been some age discrimination. All right. So far, folks, we've looked at data in a big table. We've reorganized and displayed that data in two different ways with a dot plot, a graphical depiction, and a two-way table that compares just the variables that we're interested in. And I believe that we've got just a little bit more to talk about in this video. Yeah, so if you take a look at this activity, folks, what they're doing, well, let's read this. Display 1.6, which is this one, shows layoffs and retentions by round for hourly workers. This is from your textbook as well, so if you can't see it clearly on your screen, I would recommend you get your book out. There is no plot for round 5 because we didn't have any hourly workers laid off in round 5. And what it says is, compare these patterns that you see for layoffs and retentions. And by the way, the open circles were laid off. The retained employees are the solid dots. And by the end of this, there were only 4 employees, hourly employees, left in the engineering department. What we want to do is compare that with these dot plots, which show the same information for the salaried employees. Okay, we've only been focusing on part of the picture here. These are people who are on salary, and as you look at that distribution, they had many more workers on salary than they did in hourly. And I'm seeing lots and lots of closed dots up here, but by the time you get to the bottom, way fewer closed dots. The spread here after round 5, they're all across the board again, ranging from somewhere close to 30 up through 60. In hourly employees, around 25 to 55 is the range. However, there were lots more variation up here in round 1. These people, they had a lot more folks, and the preponderance of employees seems to be at somewhat of the high end of the scale. Same thing is true here. More employees at the high end of the scale. By the time you get to the bottom, only 4 employees left. Here, many more employees left, and we still see quite a few at the higher end. So at least that's what I'm saying. For which group does the evidence more strongly favor Martin's case? Which one shows clearly that more older people were laid off? I'd have to go with the hourly workers. I really think, and this is again my opinion, you may not agree with me, but the hourly workers are the ones who seem to have, if there was age discrimination, it happened with that set of people as opposed to this set. So I'm going to say the hourly workers experienced age or more age discrimination, experienced more age discrimination than the salaried workers. Again, that's just my opinion, and yours may not agree with mine, which is okay. You will find that that happens quite often in this class, and you're always entitled to your own opinion as long as you can back it up with evidence. See, the dot plots sort of act as evidence for us in this thing. They're proving our point or supporting our point, and that's going to be our job a lot when we're interpreting statistics, is to be sure that we make conclusions that are based on the data, not what we want to see, but what we do see. All right, I'm going to challenge you right now to get it back on the website, please, and I'd love to have you try the You-Try exercise. The idea here is that we're going to ask you a question or questions that you should be able to answer after having viewed this lesson content. You know, you're welcome to review the video if you'd like, or to look in the textbook and read. In fact, I would highly recommend that you read this textbook as we go through it, because it was meant to be read. There's no way in a 15 or 20 minute lecture that I can say everything that's in the book. So the book will help you. The You-Try, the goal is to have that turned in before school the next day, so that when I look at my spreadsheet, which will show me all of your responses, I'll be able to see what I need to focus on as we review the lesson in class. So please get out there and do that as quickly as you can. Hope you have a wonderful night tonight.